To control a climate inside premises, we use air handling units, and the air must have its humidity, temperature, and volume controlled. And in these videos you can see how an air handling unit works. I have other videos, you can see in much more detail how they work. As an example here, we control the airflow to make sure that we're not forcing too much air into the building. And we all know that we can heat the air. If we use a heat exchanger, the air will pass by and will gain energy. Or the air can lose energy. We can use cooling heat exchangers to drop the air temperature. Or we can run this heat exchanger very cold to dehumidify the air. The air will allow the moisture to condense on the heat exchanger, and that will be eliminated via the drip tray. This is a very basic system. This is a system that uses heating agent. It could be glycol or water, and that glycol or hot water will be allowed to circulate through the heat exchanger by this three-way valve. And the three-way valve, it is controlled by an actuator that is controlled by a thermostat. Let's see how this system is working. To heat a building, first we have to have a heating demand, and as you'll see here, we need to set up the thermostat for a higher temperature to have a heat demand, and then the thermostat will instruct the actuator to open the three-way valve and to allow the heating agent to pass by through the heat exchanger, and the fans then moving the air to the heat exchanger, heating the airs. This type of valve, it is 0 or 100%. It is not a proportional, so we do not have a capacity control in this situation. It's very basic system. Just like I said, when the temperature will be satisfied, then the thermostat will instruct the actuator to close the valve that allows the heating agent to pass by through the heat exchanger. In that case, the premises will slowly cool down, and then when the thermostat will sense that the temperature it is too low, then you will enable the valve again, and then the heating agent will pass by to the heat exchanger. You can use a system that stops the fan, but if you use the fan, it will be good for destratification. So in this case, the fan will not stop, only the heating agent will be restricted, and you will not pass by to the heat exchanger, and then the heating will be held off by the thermostat until the temperature will go below the set point. Just like the heating, the cooling fan coil unit, we use a heat exchanger that allows a cooling agent this time to pass by. So we will cool the premises, the fans will circulate the air through the very cold heat exchanger, and then the premises will be cool. Unlike the heating, you will see underneath this heat exchanger we have a drip tray with a drain pipe. When the heat exchangers run very cold, then we have the possibility to eliminate moisture from the air, because the moisture from the air will condense onto the heat exchanger, will fall on the drip tray, and they will be eliminated via the drip tray through the drain. So I will explain to you how this system works. To cool the premises, first we have to have a demand, and we have to set the thermostat to demand a lower temperature. Then the thermostat will instruct the actuator to open the valve that allows the cooling agent to pass by to the heat exchanger. The fans will move the air to the very cold heat exchanger, and the air will be cooled. But guys, now we know cooling have a side effect, have a dehumidification, which means the air will be dry. However, because the air cools down, the air solubility will be decreased, so the relative humidity will be high. I will explain to this again. If you watch my other videos, you will understand about the relative humidity, absolute humidity, and all these things. So See, this heat exchanger is running now, but if you look underneath, it's a drip tray, and we're not removing moisture from the air yet because the coil might not be cold enough. So when you run a coil, a heat exchanger like this, you can run it a little bit warmer, just above the dew point, and then the air will be cool, but the air will not lose its moisture, its humidity. If you will have an aggressive cooling and the heat exchanger gets just above zero, then it's obvious that you will run the coil below the dew point, and the moisture will condense onto this heat exchanger, and then it will fall onto drip tray. Now you can see it. The moisture from the air is condensing onto this heat exchanger, falls onto the drip tray, and it is eliminated via the drain. For this to happen, we have to have a very reliable cooling agent, because the heat exchanger rely on cooling agent temperature to condense the moisture from the air while the air is passing by. So the cooling agent, it is very important. If the cooling agent it is not cold enough, then the heat exchanger won't be cold enough, and then the cooling process will be compromised. Although there's another problem. If the cooling agent it is not cold enough, the heat exchanger will not run below the dew point, and then the air that passes by will not allow the moisture to condensate onto the heat exchanger. As you'll see here, onto this drip tray there's not any condensed water, so the air will keep its humidity, and people will sweat on premises, because even if you cool the air a little bit, the moisture will be pretty high, and then the people will feel pretty uncomfortable. Let's see a scenario for the reason why the cooling agent might not be cold enough and where to look sometime. Probably most of you heard about chillers. This chiller I choose is very simple one. It's using 4 compressors and a heat exchanger plate. So the refrigerant passes by through that heat exchanger plate, and the water passes by through that heat exchanger plate as well. So the refrigerant is very cold, it cools the water, then the water is circulated by a pump. It goes through these 2 heat exchangers you see on the right hand side, and the fans are moving the air through these heat exchangers, and the air gets very cold. So this is a very simple chiller. Chillers can be more complicated, different type of chillers, but I'm not talking about chillers now. I just want you to understand how the water it is cool, and what can happen if it is the cooling agent it is not cold enough, and what can cause this situation. So now let's zoom a little bit into this chiller to see how this chiller looks inside. What you see with the green to the lower side of the chillers, they the compressors, and on the left hand side vertical with orange color, they the condensers. On the top we have the condensers fan. On the right hand side on the top we have the plate heat exchanger, and if you move a little bit to the right hand side with green, that part which moves, it's the pump. So how this system works? Now the chiller uses refrigerant, and who is familiar with the refrigeration process, we all know that the compressors are pushing hot gas via discharge. You'll see the gas, the hot gas line, it's are these white colored pipes. They goes into this orange condenser, and the refrigerant it is cooled into the condenser, it's liquefied. Then it continues its journey through these green pipes where subcooled reach these expansion valves, and you'll see these little arrows, yellow arrows that are pulsing. So that is the place where the refrigerant goes from the high pressure side to the low pressure side. When the refrigerant expands, it absorbs heat. So here's the trick. That black plate heat exchanger, it is the place where the refrigerant absorbs the heat from the water. By the way, water and refrigerant do not touch. So that's the plate heat exchangers. You have some tubes which divide the refrigerant from the water. Probably most of you already know this, but some people might know. I just said this. Now, this is the refrigerant circuit. The refrigerant wants to make that plate heater very, very cold. But the water, I mean the glycol, normally use the glycol, it's circulating through that plate heat exchanger and it balances the temperature. Is not allowing the refrigerant to get very cold because the water gets cooler. So the water exchange indirectly heat with refrigerant through inside that plate heat exchanger. So now the water comes warm inside, become warmer than the temperature when it's going out from the plate heat exchanger. So the darker blue color, it means cooler. The lighter blue color means warmer. So I hope we clarify this. Now the very cold water, it is pushed by the pump and it is going to this heat exchangers, to the fan coil units. Now, if the thermostat have a demand and instruct the actuator to turn on the two-way valve, then the two-way valve will allow the very cold cooling agent, which is a glycol water, to pass by to the heat exchanger. And you see now the fan moving of these fan coil units. If the fan moves, it means they are circulating air through the heat exchanger. And when the air circulates through a very cold heat exchanger, then the moisture drop and it will fall on the drip tray and it will be eliminated by the drain. As you will see, a little bit of water going out of the drain. So this is the process. Now, if you will ever come across a situation in which the glycol it is not cold enough, if you will have this type of valve which open 100% and closed, it will be very easy to identify a fault, because if you do not have a dehumidification process and you will not see a condensation and you won't see water running through the drain, it means there's something wrong. The glycol is not cold enough. If you'll have a DX coil where the heat exchanger will be an evaporator where the refrigerant expand and absorb heat, you will assume that the system is short of refrigerant, or maybe the metering device is broken or the compressor is broken. But if you use water, you have to go back to the chiller. You really have to measure the water flow temperature, not the return, the water flow temperature before the three-way valve. So it is very important, because we're looking in that point for a constant flow and a constant temperature. That will allow the three-way valve to control the heat exchanger capacity if you use a proportional control. And I will talk about this later on. But let's now keep it simple. If the water it is not cold enough, then you will not have condensation on a heat exchanger, and then you might have temperature control problems or dehumidification control problems. And I suggest that you go and have a look to see what happened with the chiller, with the main cooling device. This chiller is using two cooling groups, and each group have two compressors. as you'll see here, the group on the left hand side have a problem, have a malfunction. The compressor shows red, so something is wrong, so that group doesn't work. Now I lost half of the capacity. What does it mean? By losing half of the capacity, the heat exchanger plate will lose its capacity too, and the water, the cooling agent, will get warmer. And if you have this type of valve which open 100% and close 100%, probably will remain open because the thermostat will be set up to a temperature and the air will never reach the set point, so the system will be continuously on demand. Then it will be very easy for you to identify the fault and to say, okay, so why I cannot reach the temperature? And then you go and you will check the temperature on the flow. And also you will check the flow if you have the appropriate tools to see if you have the normal flow. It's very important. And then you will identify that the two compressors might be broken, or maybe one of them is broken, or maybe something else happened, maybe you lost the refrigerant. And then you will understand that you have to repair the chiller before you will have the right cooling capacity onto your fan coil units. So it is very important to understand how the chiller works. It is very important for you to know the cooling agent running temperature normal when everything runs well. And then you can have a look further. Also, you can look to these actuators, to the valves, to see if they close or open, but that's not really what you look to, because if you look to this as an example, to the cooling agent flow temperature, that should be cold, like almost as cold as it is at the origin. And then you will know if the cooling agent is on the flow area, have a very high temperature, then I don't have to look to this three-way valve or the actuator, because there's not a flow problem, it is the temperature problem, and the temperature is governed by the cooling capacity, and the cooling capacity of the cooling agent, it's directly connected to this chiller. And if the compressors, half of the system is paralyzed, like 2 of the 4 compressors are not running, you lose half of the capacity, and then the process is compromised. So if someone will repair your system in a winter and you say, okay, I did a great job, you don't have a good heat load into the building, and you will not know until the summer come that half of your system is damaged. And when the summer will come and the heat load will increase a little bit, the second group of compressor will try to start, but they won't be there, they're not working. And then if you have a good control, maybe it will show you a fault, or if not, you'll start to feel the this issue, because you cannot control the temperature anymore. You will never reach the set point. So just to repeat what I said, if you have an issue where you cannot achieve the temperature and your three-way valves are working, will be a very good idea, and it is an imperative that you will check the cooling agent flow temperature. And then you can look to the delta T in between flow and return, and you see if you have the correct delta T. And if you have a big ratio in between delta T, then I suggest you look to the flow. Maybe you have blockages or restrainers blocked, or the pump is slightly damaged, or someone play with the balancing valve. But first things first, check the flow temperature and make sure that the cooling agent have the right temperature. So this is it with this type of fault. If you have proportional actuators, you will be a little bit of nightmare. Go straight to the chiller, see if you have the right temperature onto this heating agent, check the chiller, and then you will see further what you can do. And now I want to talk about proportional actuators. Probably most of you know that the chillers have flow switches, and if the pump is not running, the chiller is not running, and if the chiller is not running, the heating agent will be warm, so you won't have a cooling process at all. This will be a very simple fault because you will immediately realize that you do not have cooling agent circulating through the system. You go to the chiller, you'll identify that pump is not running, and then you have to repair the pump or to repair any malfunction related to the pump, and then you will reinstate the chiller, so you will be able to have cooling process again. When you talk about PID, things are changing. Now the valve will not open 100% or close 100%. You will control the heat exchanger capacity. Programmable logic control, a building management control, or a thermostat which have a PID capability will allow the actuator to control the heat exchanger's capacity, as I said, which means it will progressively open or partially open the three-way valve, allowing only a quantity of heating agent to pass by through a heat exchanger. Like you'll see on this little video, if you look to this actuator, how is manipulating the three-way valve, allowing more or less heating agent to pass by. Now guys, you always have to measure the flow temperature. The flow temperature must be constant, and the flow before the actuator must be constant. The flow before the three-way valve. Why? Because can you imagine if you have a variable flow before the three-way valve, then the three-way valve try to control a flow which is already variable, and that's a nightmare. So the temperature must be constant and the flow must be constant before the three-way valve, so the actuator will control the heat exchanger's capacity properly. And if you'll have a problem with your heating agent, then you'll be sometime confused if you don't know what temperature you're supposed to have onto this heating agent temperature. So just be very careful. Don't always put on a three-way valve or actuator or the PLC. Don't push your default in that direction. Just try to check what I just told you, and then you'll be successful. Just like in a heating situation, when we talk about cooling, the cooling agent flow must be constant and the temperature must be constant. So the PID, proportional integral derivative, will try to control the temperature, so the temperature won't have a very big variation. Now, as you will see, the programmable logic control or a thermostat which have a PID capabilities or a building management control will collect data from room's temperature and relative humidity, and will actuate this valve, three-way valve, allowing more or less cooling agent to pass by through the heat exchanger. So see, this normally the cooling heat exchanger have two functions. One is for dehumidification, the other one it is for cooling. And when you cool the premises, as a side effect you have dehumidification, or when you try to dehumidify the air, as a side effect you have cooling. This it's something that have to be very well understood, and I have other videos. If you'll have a look, I talked about this. Now it is very important for you to know the glycol temperature, the way the temperature has been designed to be. Imagine you have a variation on glycol temperature. Now the actuator will try to compensate. If the cooling heat exchanger will not be cold enough, the actuator will open 100%. But even like that, the heat exchanger will not reach lower temperature, and his performance will be pretty badly diminished by the the cooling agent temperature. So I had this problem before, and I measured the cooling agent onto this the flow cooling agent. The return is irrelevant because you always have to have a delta T, and the difference between flow and return will be established by the designer. But if you want to have a very good dehumidification capabilities, you have to make sure that when needed, the return will be above the dew point. So what you will see here, you see the variation of the color onto this heat exchanger. The blue, the dark blue, it is very cold. The humidification will happen on that area. The rest is getting a little bit warmer. So you might not have dehumidification. The air will not, the moisture from the air will not condense on that section of the heat exchanger. So that's the way you control a dehumidification capabilities. If you have a problem with cooling agent, if you don't know the cooling agent temperature, you will always focus onto this actuator and PLC and the program, because if you don't know the cooling agent temperature, you will think your programmable logic control doesn't run well. But it is no way you will know if your software or control philosophy is good unless you know exactly the flow temperature and the flow itself. Can you imagine if the actuator will open the 2A valve 100%, but then the flow will be very weak because the installation is incorrectly done, or someone attached some other branches and it just lowered the flow, or the balancing valve are incorrectly fitted or set up. So I suggest that if you have like a cooling or dehumidification problem in a section of your building, you will check the flow temperature, and then you will realize that you might have a bad flow, or maybe your chiller doesn't provide the required temperature, or the air which passes by through the heat exchanger is too much. Maybe the heat exchanger works perfectly, but someone exceeds the maximum quantity of air that heat exchanger can handle. Anyway, so this is, if you look to this actuator, you will see it's going up and down and allowing more or less glycol to pass by through the heat exchanger, and you'll see the flow temperature is not changed, the same color, only the return temperature it is a problem. Only the return it's a variable, because I allow more or less glycol to pass by. So if the flow it's less in the heat exchanger, it's obvious that the cooling agent will gain more on heat onto the return, and this is the control capacity of a cooling system. Thank you very much for watching this, and let's look further how the actuator works now. I'm going to zoom a little bit into the actuator. This is a PID system. This valve have the capability to open and close from 0 to 100% progressively. This is a great control, so you can control the heat exchanger cooling or heating capacity by opening or closing the valve progressively, and this valve controls the flow. What can I say? I told you the couple of things. You have to make sure they in good condition, otherwise the cooling or heating agent temperature and the flow should be constant. This is about this type of control. Now there's not too much to say. I just want to thank you for watching my video. Please look to the other videos if you want to learn more about heat recovery systems. You will learn that they're not actually heating systems. And I have some other videos about solar panel heating strategy. You can see how can you train data so you evaluate the building's heating and cooling. You learn what can you do to avoid ice and up phenomena, the bad things about using defrost by using the timers, and what can you do to avoid small heat exchanger which run very cold, and so on. Thank you very much for watching my video. See you next time.